All right, so we're starting off with like these first three. So basically, we're gonna start with this one first, right? We're finding the exponential growth, right? Exponential growth or decay. So right here it says, for each equation below, identify the equation as exponential growth or exponential decay. So the way we find this, right, is well, they give us two different numbers, right? So they give us y equals 3.34, right? And they give us 1.67 in the parentheses, right? So these are two separate numbers and they mean like two different things. So right now we're just focusing on the on this number right here, right? So the way to find exponential growth or decay, so like for example, right, if we were to have a number like 1.5, right, I know that's exponential growth because the number is more than one, right? So 1.5 is exponential growth, 2 is exponential growth, 3, 5.6, those are all exponential growth, right? That's exponential growth. And then, for example, numbers like 0.5 or -1, -3, those are all exponential decay, right? Because they go lower than 1. So anything greater than 1, is growth, right? And anything less than 1 is decay. So I can tell this, right, is exponential growth because 1.67 is bigger than 1, right? But if it was like, for example, right here, right, I can tell this is decay because the number right here is 0.54, right? And that's less than 1. So this one would be decay. And so you just apply that to all the parentheses, right? So that's the first one. That's how you find the exponential growth or decay. And then now you got to find the initial value. So the initial value is really easy because it's basically just like, you see these numbers, y equals. So y equals, that's the initial value. So that's just the answer right there. The initial value is just the y-intercept. So y equals anything is the initial value. So y equals 3.3, the initial value is 3.3. Y equals 8, the initial value is 8. Y equals 4.5, the initial value is 4.5. So, that one's really easy. Now you got the growth or decay factor. So the growth or decay factor, right here, right? The growth or decay factor, that is just this number. So the answer is just that number, right? Whatever is in the parentheses, that's the answer. So the growth decay factor for this one would be 1.67. The growth or decay factor for this one would be 0.54, right? And the growth or decay factor would be 4 here. Well, obviously, for like this one, that's the growth factor. For this one, it's the decay factor because it's less than 1. But it's just the number, right? In the parentheses, that's the answer, right? And now you have the growth or decay rate, right? So basically, the growth or decay rate, you're just trying to find the percentage at which it's growing. So, for example, right, we'll take 1.65 again. So you take 1.65. Hold on. Let me get my lamp in here so it's not shadowing. So 1.65 is, oh, fuck. There we go. Shit. Okay. 1.65, or not 65, 67 is, has a growth factor of 67%. So if it was a growth factor of like, if it was a growth factor of 100%, then it'd be like 2, right? But it's 67% because of the 0.67, right? So that's how you do that, right? And that's how you do. So that's really all you're answering. You're just answering the exponential growth or decay, which you find by like, you just basically see if it's growing or decaying, and you just find that by whether or not it's bigger than 1 or if it's lower than 1, right? Or if it's equal to 1, then it's growth. And then the initial value is just y equals whatever, right? The growth or decay factor is just the number in the parentheses, and the growth or decay rate is just like the percentage at which it's growing or decaying, right? And that's the first part. So I'm gonna end that video.